Hey, everybody, welcome back. Let's see chapter 2. That's what we're gonna do, chapter 2. Chapter 2 is on organizing data. Talked a lot about what types of data we have. We're gonna explore that some more. So the first major topic here, section 2.1 is on frequency and relative frequency. Now they're related. How dare you? I don't get that very often. I got a fuck you this weekend too. I was so proud of myself. What is from a former shoot, and I was taunting them, I was egging them on. And she knew I had it coming, as soon as she did it, I was like, thanks, there we go. Now I can stop. Here's the story here, in spring of 2020, yeah, right when the pandemic started. This MFer up here was teaching 3 stats classes. You know what a pain in the ass that is? You're like, with holidays throwing things off. You're like, did I teach you guys this shit yet? Or it's not fun. So, but I had a lot of stats students and we were doing stats, so I asked him. What time of day do you do your best work? I gave him 5 choices. I said, you could say morning. You could say noon. You could say afternoon. That's really vague. You could say evening. Or you could say late night. I did not tell them what these time ranges included. Noon for some people is like 11 to 1. Others, it might be 12 to 2. Morning for you might be like when you wake up, 6 to 9. Others are like, nope, that's just like 9 to 12. I didn't actually specify, I let them like figure out what their time slot was. I didn't say like, when you do your best homework, I just said when you do your best work. So if they were thinking about other stuff in their life, like they could just decide. And I had 101 people respond. And I have a list of their responses somewhere, I have it saved somewhere, I'm sure. But rather than telling you what 101 people responded to, I'm going to summarize that data. 25 people said morning. 30 people said noon. 20 people said afternoon. 17 said evening. And 9 people said late night. And if you add that up, that's 101 people. These are called the frequencies. And plural is IES. Frequency is the number of times a particular response is given. Or obtained, I'll say obtained. We're not always asking questions, sometimes we're just doing it through observation. frequency can be somewhat helpful, but like. If you didn't know everything, and I just said, I asked this question and 25 people said morning. And you didn't know there was 101 people. You wouldn't know if 25 is a lot or a little. If I had only like 30 students responding, 25 is like almost all. If I asked like 300 students, 25 really isn't jack shit. So like frequency can be helpful. But relative frequency tends to be more useful. I'll say more useful overall. And the way we can calculate the relative frequency. For RF. Relative frequency is F divided by N, which is frequency divided by sample size. Which is like total number of responses. Pause and let you guys process that shit a little bit. This whole N being the sample size is throughout all of stats. While I'm on it, capital N refers to population size. Little n is sample size. Get a chance to write it down, then we'll calculate it. Robert coming in? Did a guy come in and grab his mouse?
Yep.
Fucking oblivious. I didn't see, I was busy yapping and I didn't fucking see him. Like the mouse is there, I'm like, where is he? How far away did he fucking go in 5 minutes? Fucking mock speed in his car, no. Came and grabbed it. Huh. Good time. That's what we call attention to detail. Alright, so let's figure out our relative frequency for those categories. I'll relist the categories and walk through how I get it and what the value is. Some lines in here so that it's easy to track. What's going on, what? So in the general form, each of these is just a fraction. I take the old frequency and I put it over the number of people that responded that way. So keeping that page where I can see it. 25 said morning, there was 101 people, so 25 over 101. Noon, 30 people said it. Total was 101, so we'll put 101 on bottom. Afternoon was 20 over 101. Evening is 17 over 101, and late night is 9 over 101. Again, still probably not the most useful thing in this format, but we're not done yet. Wait, there's more. There you go, 90. If I do 25 divided by 101, that's how, what a fraction bar means is division. For those of you that forgot, division. I'm gonna write all the decimals for now. And we'll talk about rounding in a second. Because rounding is where you will make the most errors. 24752. I hate the way this psoriasis shows up on the camera. I'll put my glove back on. It's not feeling with it. There we go. I'll do the same with the 30 divided by 101. And follow along on your own calculator if you got a calculator with you. Make sure you get the same thing. It's kind of neat. It looks like every 4 numbers it repeats. Gotta be related to the 101 part. Really. These are called the proportions. Proportion. Yeah. My red numbers here. Proportions are always between 0 and 1. It can equal 0 or it can equal 1, but it's always some decimal between it, for the most part. The fractions are also proportions, but like they're less readable for a lot of people that way. So this is gonna happen a lot. And when I say a lot, I'm gonna go with like. Almost every single time there's a fucking math question in the homework, they're gonna tell you to round. And you will fuck this up, no matter how good you are, you will fuck this up. No matter how well you know rounding, you will get distracted and you will fuck this up. So if you get an answer wrong, and it tells you you're wrong, it's not gonna tell you you rounded wrong. Pro tip is always check to see if you rounded correctly first. I'm gonna say, at least half the time a student emails me and says. It says I got the wrong answer, but I'm sure I did everything right. Here's the problem, and they send me to the ask my instructor thing, and I go look at it. And I see their answer, and I see the correct answer, and I can see right away that they just rounded wrong. Yeah, at least half the time someone emails me and says they got it wrong. It's a rounding error. So the way rounding works is they'll either tell you. Number of decimal places. And let me just make a number real quick and illustrate. We count number of decimal places going this way. Count decimal places this way. Maybe I should have just done 1, 2, 3, 4, 5, 6, 7, 8, 9, because then I could just say the decimal is the one. I want you to rely on it. So like the 9 is the first decimal place, 8 is 2 decimal places, 7 is 3 decimal places. It'll tell you that. Or it will use tenths, hundredths, thousandths. And I'm pretty sure if it goes beyond that, it will switch decimal places. It might say 10 thousandths, but I doubt this. The 10th place is that spot right there. The 100th spot is right there. And the 1000th spot is the 7. That's where the 10 thousandths is. Next one. That's because 0.9 is the same thing as 9 times 1/10. 0.08 is the same thing as 8 times 1/100. So that's where the tenths and hundredths come in. It's a fraction thing. But that's the denominator, the naming they're gonna use, the nomenclature. For our sake, on this problem, I'm gonna say, let's round to 4 decimal places. So I'm gonna underline those values, how many that is in each of these up here. And if I do it here. Okay. So for rounding, look to the number to the right. Or look to the number to the right. If the number to the right is between 0 and 4, you round down. And if it's 5 to 9, you round up. Round down is the equivalent of. Leave it alone. And round up. Is go up by 1. In both cases, whenever you've done that. You chop everything else off. And I'll show you in a second, we're gonna do it on all these. So starting with the top one up there. The 2 is between 0 and 4. So I'm gonna leave it alone. I'm gonna round down, which means leave those numbers the same. And basically chop off everything else after it. In fact, on all 5 of these, the next number is between 0 and 4. So all of these are gonna be round down. The one where it's gonna be different is this one right here. This one right here, the 5 is bigger, so what I'm gonna do. If I round up 9,876, I have 9,877. And then I chop everything else off. I hope you've all seen that before. I hope most of you are comfortable doing that, but I wanted to make sure I walked through it pretty clearly. Because you're gonna get more shit wrong on this, no matter how good you are. I fuck this stuff up all the time, it only takes your fucking phone going off, dog barking, car alarm. You got TV going on in the other room and advertisements pop up and the ads get louder, I know if you're streaming in general. No, streaming even has ads now unless you're paying the extra, those sons of bitches. Streaming used to be ad free. Okay, everyone go with the rounding? Don't round and then round again if you need to go to a lower value. Always like. Restart. I'm gonna do a little bit more with this one right here. But I wanna point this out here. Don't round and then re-round. Let's say I have 0.945. Two decimal places. I'm gonna use DP for decimal place. This is 0.95. The one decimal place. This is 0.9. If I tried to do 2 decimal places and then round 0.95 up. Well, the 0.9 has to go up because the 5 is next to it. This would be 1.0. So like if you round and then you re-round, you can get a mistake. Are you all right? Need some water? Okay. So that's why I say don't round and re-round. Oftentimes it won't cause a problem. But like in circumstances like this. It does. Finally, in this section. To go from a decimal to a percent. We multiply by 100. What that does, the shortcut is. Move the decimal point right twice. So like on morning. I had 0.2475. I'm gonna move the decimal point to the right twice. And I get 24.75. And then I slap on the percent. Doing this fractions to decimals to percents and going the other way. You're gonna make so many fucking mistakes doing this shit. So easy to forget. And even when you know, it's easy to make a mistake. So check this stuff on each one. I'm gonna apply that to each of these up here on my list here. So if I move it right twice here, I get 24.75%. If I move it right twice here, I get 29.70%. If I move it right twice here, I get 19.80%. If I move it right twice here, I get 16.83%. And if I move it right twice here, I get 8.91%. Questions? Okay. And that's a little bit more meaningful, isn't it? If I say morning is 24.75%, now you like, no matter how many people it is, you know that it's like what percentage it is. And we all have like a basic idea of what percentage it is. The bigger the percentage, the more of the whole it is. Just gonna rewrite them down here for my own sake of scanning it. If you've already have it written down again, you don't need to write it again. In terms of what the homework will take. Sometimes. They want you to put the percent symbol in there. Usually they don't. Usually they'll have a little percent symbol listed there next to it, and you just gotta put the thing. Pay attention to the problem. Most problems. Don't ask you for the percent version, they ask you for this version, the proportion value. So most homework problems. HW is shortcut for homework. Most homework problems want the proportion, not the percent. But read to double check. To find out. The hardest part of this class, stats should really be called word problem class. Almost all the problems in this class are fucking word problems. Once you start doing the math, it's all word problems. Thankfully, the computer will do most of the math for you, or the calculator will do most of the math for you. But like just the translating of the words to like the math, knowing what they mean. Also of note. For the homework. Like I had 0.1980 before the percent. This is identically equal to 0.198 without the zero. Homework should take either way. Even when they ask for 4 decimal places. If you put in 3 and it tells you you're wrong. Double check that you did your math right, and if your math looks right, just add a 0 and see if that fixes it. Usually the one, I can't think of any problems like where it doesn't allow you to chop off a 0. The only reason you would leave the 0 in is to show that you didn't round that off. And it's important in sciences, but less important in statistics. Yeah.
So they asked like, what's your portion for morning and noon? Should you the portion individually first? Round the answer at the end.
So they say like if do morning or noon,
So
or both, do morning and noon. I would add them up first. Then round. Only because sometimes you might have rounded up on both where you. And it ends up being, it might change it a little bit, you're better off rounding ahead of time or afterwards. It will ask shit like that, it'll give you like 6, what about doing 2 categories at once, that is a legit question, it happens. So, in the software. Our homework system. Uses StatCrunch. I'm gonna say at no extra cost. If you're paying for the homework system, you can get StatCrunch. It's part of the homework system. I'll show you how to access it. I'll walk you through it in a second. When you're done with this class, if you ever really want to do stats, you could probably figure out how to do most of this shit on Excel. But like doing it on Microsoft Excel, the formulas are a pain in the fucking ass. Like I don't wanna, it's fucking tedious as fuck. There'll be like parentheses and do this number, comma, this number, comma, this number. What the, I don't fucking remember what's in each one. It's a pain in the ass to do Excel. StatCrunch is surprisingly easy. It's a lot of drop down menus. All you gotta be able to go through menus and pick the right thing. So I tend to abbreviate StatCrunch, I will say SC. Oops. SC. Sometimes I'll write StatCrunch, but if I write SC, I'm talking about StatCrunch. You will get tired of writing down the word StatCrunch. And let's go explore it, and then I'll be, if you, afterwards, I'll write down like a written description of what we're doing here. But I wanna make sure everyone's got what's here written down before I change things. Yeah, I know, it's almost break, I'll take a break if you promise. Anyone need this up longer? Okay. I'm gonna move that over to that, I need to change what's shared on Zoom, cause. The video is gonna be fucking psychopath. This is like if you're in the homework screen. Like a lot of times the problems itself will give you the option to do StatCrunch. But if you, when you're doing like your project or other stuff, you can always get to StatCrunch over here. So it's on the list here if you're doing it on a laptop. StatCrunch. And visit the StatCrunch website is the most helpful one, the one you'll do the most often. They even tell you how much you can buy StatCrunch for if you want to use it after this for other shit. So unless you're working with like a pre-existing data set or like your own data that you've done, you'll just open StatCrunch. I'll show you what that looks like real quick. It looks like an Excel spreadsheet. There's a lot of drop-down menus. Rather than typing in a bunch of fucking data, just to give you an example, I'm gonna instead open up one of my data sets. Let's see, the hell is that? I'll have to look at that in a second. Let's go with. Oh, that's fun, let's do that one. So otherwise, StatCrunch does, like when you put stuff in, you'll have a way to actually, like, if when you're doing your project, if you do survey questions. And you have like a tab where you want them to type it in, they can actually answer the questions and it fills in this grid for you, which is pretty neat. But otherwise, like each row is one person or one set of entries. And like you try to kind of have a row header on top. If I want to find the frequency of people that said brown hair versus blonde hair versus other stuff like that. I don't know why the first row is extra. I'm gonna delete this first row real quick. I can do edit and then row and then delete. It's repeating it and I don't want it. There we go. We can go stats, tables, frequency. So I'll write that down in a second. I'll actually show you another spot where you can find like a nice little like PDF document of where all the commands are by section. But stats, tables, frequency is how we'll get to frequencies. And we wanted to look at hair color, we said. And you can actually tell it to do both frequency or relative frequency. Right now, both are highlighted. I can choose one or the other by clicking on it, or I can hold down the mouse button and drag over it. And now it tells me how many people responded, 182 responses. 61 said black hair, 13 said blonde, 96 said brown, 8 said other, and 4 said red. Not a lot of redheads. Then they give the relative frequency. Notice that it's not with the percent. This is all in the proportion version. Okay. Another way that you can get to the same step that we'll see in a second is if we do a bar plot with this. And when this is like 2.2 as I'm graphing, but I'm going to show you while we're here. If you have all the data, which is like everyone's individual responses like we do, you select with data and you just tell it which one to do. Whether you want frequency or relative frequency is here. The other thing that's pretty handy is paying attention to order by. I didn't show that over here, I'll go back and show that in a second. Value ascending is when it does. When the thing is words, it goes alphabetical. Like black is before blonde because the B's match, the L's match, but A is before O. So they put black before blonde. This is going in alphabetical order. That's called value ascending. If I do that here, it shows up like this. And if I put my cursor over any column, it tells me the frequency. On both of these, in StatCrunch, this is always something really useful. If you're like, I clicked a bunch of shit and I clicked something wrong that I didn't want. You can always click on options and go back and edit whatever you did. So it shows everything you just highlighted. I am editing the frequency table real quick. I got frequency and relative frequency. If I change the order by over here. Value descending will give me backwards order. We'll do like red first and black last, backwards alphabetically. If I say by count, it'll give me the largest, or count ascending, it starts with the smallest number, which would be the 4, and I'll go up to the largest number, which will be brown. And if we do worksheet, it's basically what order did they show up on this? Brown was the first response. Then the next newest one was other, and then black. If I say by worksheet, this is going to give me the frequency table based on that. Brown was listed first, then other, then black, and it goes that way. Sometimes you want that. Sometimes you want by worksheet order. Usually alphabetical is fine. Usually you don't need to change it. And show you like count descending real quick. Count descending has the largest count first, and descend is go down, so the count goes down. If I edit this one, the graph, I can change this to say relative frequency. And the graph one actually has another option that's pretty nice. If you scroll down, it says value above bar. Value above bar is really fucking handy on the graphs. I'll show you without value above bar. That's relative frequency without the value of the bar. And if I want to find out any of the relative frequencies, I have to put my cursor over it. You get tired of doing that. If I go back in and I change this to say value above bar, if I can do it. Why not? There we go, not wide enough. It gives me a value of the bar. And opening it wider doesn't add more decimal places, but if it's too narrow, it cuts it off. Yeah,
What's the difference?
I can look at this right here and see the number without having to look at anything else. It's ease of reading it.
Okay, alright.
Like the answer, the value isn't different. Other than it's rounded. Here they've rounded to 3 decimal places on all of them. On the 439. They rounded up. 0.0439. 3 decimals would have been 0.043, but they rounded up to 0.044. So it rounds here as well. You can also look at a pie chart. Pie chart does the same thing. We'll do with data. This is kind of the one where like paying attention to value ascending or worksheet order. A lot of times the homework does it in worksheet order, does a specific format. And if you don't do it in the same format, like the pie slices are in different spots. It's like the graph won't look right. You'll be like, which one is this? So like figuring out which one looks best. Oh, I gotta tell it. So you guys have seen pie charts, hopefully. Hopefully you've seen a pie chart before. This one, pie charts are kind of nice because they give you the frequency. And the relative frequency as a percent. It's got it all in one chart, it's kind of nice. And it's pretty. Everybody likes pretty, right? Oh, that's gonna bake your noodle when the colors don't match the words, that's always fun. Okay, back to the writing. And I need to change the screen share on Zoom. So I mentioned for frequency or relative frequency. In StatCrunch. We will do stats. Tables. Frequency. Then you pick the column or columns. You want. The order. You may want to adjust. And then you click compute. Add something to Canvas real quick to. So you know what you're looking for, it's pretty fucking helpful. I've gotta find it. There it is. Oh. So I'm gonna go back over to Canvas real quick and show you where you can find something helpful that you like. Change it on Zoom real quick. Ah! There we go. So in the module. I have in the orientation module added StatCrunch Tech Help and Stats Formulas and Table. This top one is the more useful of them. In fact, if you like having printed shit, printing it is pretty handy. You can also download it so it's on your laptop and you don't have to go looking for it. Just want to show you what it looks like so you're like, oh, this is fucking helpful. How long is it gonna take? Probably downloads quicker than it just loads on this. Yep. Downloaded quicker than it was there. For most, these should be all pretty accurate. They're telling you by section. We've just covered 2.1. Doing frequency or relative frequency. It says enter the raw data, do stats, highlight tables, select frequency. And tells you what to do. Does it by each section. Just talks about the bar graph we did as well. We didn't have summary. Ooh. You don't need to enter the summarized data. You can do the direct bar graph without it, so some of this is a little, there we go, bar graphs from raw data. So like it tells you what to do with the raw data. How to do side by side bar graphs, pie charts with summary data or raw data. We're gonna be looking at some of this in a second. It's handy, it's by its section for the entire course. So having that, like, it gives you quick, like, read just instructions. Let's take a 10-minute break. Pause record. Give you all a chance to. All right, we're resuming recording. Let's take a look at 2.2. Normally, I use that 10-minute break on Tuesdays to talk about, are we gonna talk about Tuesday or what's going on for dinner? Cause at this point, it's fucking dinner time and I'm thinking about. I know my wife told me she wants Curry Pizza Company tonight, cause they have half off pizzas on Tuesday nights. Or at least they did last semester. It's gonna be really disappointed if I drive over there and it's not half off. So 2.2 is on bar graphs versus histograms. So for bar graphs, we just saw what they look like. That's a good old bar graph. And a histogram would have the same graph like this. Trying to keep all the rectangles the same width, but I kind of fucked up. They should all be the same width. Histogram on the same thing. And we'll look at it in a second on StatCrunch. How did we get to both? How to graph both? Look at the differences there. So let's look at what they have in common. What's bar graph specific and what's histogram specific. So we'll call them commonalities, what they have in common. We'll have what's important to a bar graph. And what's important to a histogram, and assuming they are different. As we can see, they both have rectangles. And what you're not seeing here, because I didn't put them on there, they both can show frequency or relative frequency. Now, how do they differ? On the bar graph, the bars don't touch. And on a histogram, bars do touch. That seems like an unimportant thing, but it actually is important. If there's a gap in the histogram, it means there's no value for that set. Which makes sense. Because on a bar graph, I don't even think they show the bar, but a histogram will show a gap. Bar graphs, you can do categorical or qualitative data. And I'm pretty sure you can do quantitative. Let me check real quick. I still have that data set open. Yeah. Because age is a number and they got age there. Or quantitative. We have put a little asterisk next to these, since they show what lines are which. Histograms is quantitative data only. On a bar graph, they can be vertical or horizontal. Horizontal bars being the rectangles going to the right kind of thing. Histograms are only vertical. This next one we saw, this we can put in any order we like. That was doing like the count descending worksheet, that shit. On the histogram. It's sequential numbers only. Sequential x-axis. Which is the bottom row. They gotta go up. The numbers go up from left to right. Sequential means in order. And another difference, which is probably the least of the importance on them. This one you can do multiple data sets on one graph. Like you can do a bar plot with guys versus girls kind of thing for each group. In fact, a worksheet will show you how to do it, that PDF. This one on the histogram is one data set per graph. Because they are sequential and they are touching, they don't make it, so you can't mix them up like have it alternating like you would with a bar graph. All right, you're not gonna be doing these by hand, I mean, you could. But in StatCrunch, how do we get to them? We saw the ones with bar plots was graphs, bar plots. And then you had two options, with data or with summary. With data, and this with data with summary shows up on multiple lists, and it means the same thing on every list. With data means every response is recorded. In the spreadsheet. With summary. Just the frequencies are listed. Like my question about time of day thing. About best time of day to work. So depending on how you have it listed in there, you gotta choose one option or the other. For the histogram. Since it's a graph, it's under graphs. Histograms. It does not have with data or with summary. You must have data. No summary. And columns must be with numbers. Columns must contain numbers. For the quantitative data part thing. And it won't give you the option. If you, you'll see, I'll show you graph bar plot list and graph histogram list. And every column that has a word in it is not available on the histogram list. The histogram list of the things you can do graphs on is very, very slow. Anyone still writing that down? I see a nod. Come on. If I don't see your nod and I go to change it, speak up. Say, hold on a second, please. Stop, fucker. I dare you to go stop, fucker.
What happened?
I don't know, I might fucking laugh, there's a strong possibility I'll laugh. If I think you're saying it hatefully, I won't laugh, but if I think you're saying it because you think it's funny, I'll fucking probably chuckle. I like to play along, I like to joke. I know someone's gonna try it now, and it's probably gonna be you.
But
I just got, I think I told you guys earlier, did I tell you guys earlier, like, she told me to fuck off this weekend, I was happy with it? Well, she's not a student, she was a student, she actually works in the Mesa Center now, she's working on her graduate program in mathematics, but she used to be a student here. And I was provoking her, being a jackass. She wouldn't respond, she just gave me a dirty look, and she finally gave me a fuck off, Jones. And I said, there it is. All right, I'm gonna go. Everyone ready? Yeah, everyone looks like they're done writing. I am going to take us over to PC. So notice if I do graph bar plot, I have those options with data with summary. When I do graph histogram, nothing pops up. When I do graph bar plot, so the only way to do histogram and bar plot on the same thing is with doing with data. Because there's no summary. Notice for the bar plot, every fucking column shows up. If I do graph histogram, shit, those are the only 4 columns that show up. All the ones with words have been eliminated from the histogram list. Okay. I'm actually gonna cancel that. We're gonna play around with age, but I want to show age as maybe do a table on age first. Show you guys a little of something that happens. I'll just say frequency for now. And I'll do value ascending because that's how a histogram would be. Notice it says when I try to do this, and I don't know how well you can see it back there. It says, whoa! Lots of unique numerical values for age. Do you want to turn on binning for this procedure? I'm going to say okay, and then I'm going to do it again without turning it on. So here they decided to do this 10 to 20, 20 to 30. We'll talk about what this bracket in parentheses means in a second. That's with binning. If I do the same thing and I tell it no, just leave a regular. Wait, I meant to do table. Stats tables frequency, age, just frequency, and I say that. It gives me, I need to move the zoom bar out of the way. Every possible age answer and how many people said it. At some point. This is a fucking unruly amount of numbers. You really, at some point, you don't want to have the table. Right? Like a full table like that. This one, I'll do it again from scratch. We can tell it if we want to, how to bin ahead of time. Ten to 20 sounds good, like every 10 years sounds pretty good, but like. If you wanna make sure you separate out like underage. Like 18 and under, or under 18, you might wanna have a different bin. Let's say you want it only every 4. You tell it what number you wanna start with, I'll say. 10's the lowest number listed here, but I'm even gonna say start at 0. Let's see what happens if I say start at 0. And we're gonna say like every, I don't know. 5 years. So start tells me the first number to use and width tells me like how many years to put in each group. If I did it over here, this would be. The way the computer did 10 and 10. It started at 10 and each one is 10 wide. I'm gonna start, well, maybe I'll start at 10 and go with 5, just to show it a little bit easier. And so now. That's how it's doing it kind of differently. So you can change the way the binning is set up. And bin is like. There's just too many results here, so we're gonna make a bin that says 10 to 15-year-olds go in this box. 15 to 20-year-olds go in the next box, and I'm like, wait a second, how can I put a 15 in both boxes? I gotta pick one. So we'll talk about which word decides to put the 15, like the ones like you can see like 15's here and 15's here. Which box do we throw the 15-year-old in? 20 and 20, they do it on all these. We'll talk about that in a second when I go back to the camera. But that's doing the table version. I'll leave the bin one up from this one. If we go to graph bar plot with data. I'll leave it as frequency, I'll leave it as order ascending. I'll click on value above bar. I don't know that it has, oh, it does give me the option for binning. But it didn't tell me, like I didn't get to choose. So the way it looks is like skipping some numbers here for some of the bars. If I widen it, it should show all the same shit. So the computer will choose how to bin on its own. 10 to 20, like doing every 10 years was fine. It does not know that it's looking at years though. Okay, it doesn't know what it's looking at, so sometimes choosing to bin yourself. What number range to have in each group is more helpful. We'll walk out all the binning and stuff on paper in a second. If you don't do binning. You get that glorious bar plot that has way too many fucking columns. And you're like, this is fucking completely unusable. At some point, you're like, I can't read that, right? I can't read that. So a lot of times binning is the right choice. We look at histogram on age. We do have that bin option. That's kind of nice. Let's see what it defaults to on its own. I'm gonna click value above bar just to be helpful here. And if I put my cursor over it, or if I widen it, maybe if I widen it, nope. Widening it still doesn't show the values very well. So if I put my cursor over a bar, it's saying 15 to 20, which is like 5 years. So if I want to, like, this doesn't have the same like binning as the graph or the bar plot. And that's kind of like, I want them to look the same, so I'm gonna go in and edit, and I'm gonna say start at 10. And do a width of 10 so that it looks like the bar plot. So that's how they differ like that way. That histogram with regular bidding actually showed something useful. Notice that there is a column here that has no box. I put my line on the bottom, it says there was nobody in the age 70-75. This one, there was one person from 75 to 80 that responded to this. I kind of think it was my mom. I don't think it was a student. Cause my mom was that age at about the time I did this. And I'm fairly confident, unless they were online and I didn't know. I've had some people in like the late 60s. I don't know that I've had anyone in the 70s yet, though. You see a lot of age students at community college, it's kind of cool. But it shows up as a gap. Whereas this one, I don't know that it has a gap. I can check to see if it has a gap by doing every 5 years. I wasn't able to change the bar plot. Never mind, I can't do that. Wait, I had one other one in there. I can change that one. That one had editable data. I can turn on bin, I could say 10 and 5, so it looks like that last histogram. And notice it doesn't show the 0. It says 65 to 70. This has a 70 to 75 listed as 0. They just completely eliminated it from here. It's worth noting, because if you're ever looking at the table and they ask you to list all of them, you have to list the 0, even though StatCrunch didn't list the 0. It will happen, okay? So let's go back to the paper and take a look at like what these numbers mean. Why, where does the 15 go on this? Where does the 20 go on this? Why is there a bracket and a parentheses? Talk about that bracket and parentheses. We saw when we did this. I'll use the original thing. No, I'm not. I'm gonna use the 10 with 5. We saw 10, 15 parentheses. And then we had bracket 15, 20 parentheses. We had bracket 20, 25 parentheses. Bracket 25. 30 parentheses. What's going on here? This was our age thing. Age bins. So I'm going to use the letter X for age here and what I'm about to do. This one has 10. 10 is less than or equal to X, which is less than 15. And since I plan on writing a little more with that, I'm going to come down here and spell out what that means. When assigning people to this bin, or entries to this bin, put all values from 10 up to 14.999999999, a bunch of decimal places. Keep going. Which is like up to 15, but don't include 15. That's another way of putting it like that. So for the numbers that appear in two groups. In two bins. It will count. In the bin. Where the number is on the left. Maybe I'll put it next to it like this. 10 to 14.99. And I can go down the list and do this on each of them. 15 is less than or equal to X, which is less than 20. This is 15 to just a little bit below 20 is 19.999. And I'll only do like, even though there's a full list, I'll only do these four here. This is 20 is less than or equal to X, which is less than 25. This is 25 is less than or equal to X, which is less than 30. Now. This is going to, and I promise you, it's going to annoy the shit out of you. And you'll be like, I want to slap somebody. Please don't slap me, it's not my fault, I think it's stupid too. This is what the homework wants. Wanted by homework. And this is what you get. So you have to do some translating. They'll usually tell you how many decimal places to put. I'm absolutely confident there's a problem in there that has like in the thousands. Like 5,000 to 10,000. And they don't want you to do a decimal there, but they do want you to go. Like if it says. 5,000 to, they won't have a comma there, it'll just say 5,000, 10,000. The computer is gonna want you to put 5,000 to 999. And I'm gonna do the next one because. Just to illustrate what you'll put in the computer. I'll put commas here, because it's more useful to read. You're subtracting one from the previous number. That's on a population where they're like not gonna have any decimals. And I'm sure they'll have one like where there's a missing value. So if there's a missing value, you have to deal with that too. Very frustrating. Oh, pro tip. Don't put commas in. Homework answers. Unless it says to. I can't think of any problems offhand in statistics that has that. Usually it's in like the other math courses. But like if you try to enter 10,000 with a comma in it, it's gonna tell you it's wrong, even though it's right. Because it doesn't recognize comma as a valid thing, so it's not gonna accept it. Okay, We got a little bit more to talk about here, but not a lot. Just gonna put up that stuff on the left again real quick to give you some more terminology. Like we had that 10 to 15, 15 to 20, I'm only gonna show two of them here. Yeah,
One from that last sentence.
subtract one if they want a whole number,
Okay,
like population, you're not gonna say like 0.1 of a person.
okay,
Although Trump might with his, I bet he goes for the 3/5 of a person policy. I can take it back. But I wonder if someone's gonna recommend that, like. Back in the day, some people only got like up for voting purposes, they only get counted as 3/5 of a vote. That's some fucking bullshit. Alright, so these are called classes. Or bins. The ones on the left are called the lower class limits. And the ones on the right are called the upper class limits. That sounded like a sigh, like we're not having fun. Ow. You should be like, this should be like, I wanna kinda take home my notebook and like. Put it underneath a magnet on the fridge and show off to my family how awesome this was today. Sometimes they just say lower class and upper class, but that sounds like. I don't even wanna say it, with but the way the world's going today, so lower class limits, it's the limit, it's like a boundary. Nothing can be outside these limits. If they ask you for a class width, and I know they will. Class width. To calculate it is you subtract. Consecutive lower class limits. So I've only got 15 and 10 here, but if I reference what I had over here. 15 minus 10 is 5. 20 minus 15 is 5. 25 minus 20 is 5. Just looking at doing 2 in a row. Notice they're all 5, the class width is 5. Alright, I'm gonna introduce you to 4 different like graph shapes real quick. We'll go over it again. Thursday, I'll think about what day it was. So we've got 4 common graph shapes. This usually goes with the histograms. All the bars are roughly the same height, maybe not perfect. But they all look roughly the same height. I can have bars that start small and get bigger. They can do big leaps or little leaps. They can do stuff like this. But it like goes up and then goes back down. And it's about the same on both sides. This one is called the uniform distribution. like a uniform, like a police uniform or firefighter uniform. Uniform is kind of like they all look the same. And in this case, they're talking about the size of the bar, how tall it is. If you've ever seen a graph or a little picture of a bell. This kind of looks like a bell. They call this a bell-shaped distribution. And like on Thursday, we'll go over like what kind of things you can expect to kind of see in each group. Some things show up in one group in particular. Then we have like one that's got a lot of like values that are kind of low on the left. They kind of get steep for a second. And then they taper off real quick. Or we could kind of have it where the other way, where it like rises up really fast. And then slowly tapers off. These have very particular names, and I think to help you remember the name, kind of helpful to show you where they get the idea. Like if we pick like the biggest column here. Biggest column here. Going to the left and to the right are called the tails. That's the left tail, and this is the right tail. We could kind of do that with the bell-shaped distribution too. Left tail and right tail. The bell shape, they're about the same length. They look like if you put a little arrow underneath them, they're about the same length. So that's like kind of like the bell. On the other ones though, like one tail is definitely bigger than the other tail. They name it after that tail. This graph is called skewed left. This graph is called skewed right. It matches the longer tail. Oh, these barking spiders, you gotta watch them in here, they need to spray more often. Thankfully, they're usually not venomous. I have it downloaded already. I do. I want to show you guys something real quick. A final note on like bad graphs. This is kind of real quick. Change my share here. I don't think I got that. Misrepresenting data. So if we look at this picture real quick. Oh, wow, you can't see that very well. All right, undo. Maybe I can enlarge it a little bit. This says life expectancy in year. And this says like the years, 1950 to the year 2000. This looks like the life expectancy was really fucking low. Does it? Like the death rate was fucking astronomical. And then all of a sudden in 50 years, we figured out how to save everybody's life. If you actually look at a list of numbers here though. The one on the left is 68.2 and the one on the right is 77. That's less than a decade. This looks like a hell of a lot more than a decade. This looks like we're not making it to 18 years old. And here, they're fucking living to a long old fucking life. So like this is misrepresented because the number here starts at 68. It doesn't start at 0. They will do this a lot because if it started at 0, we don't have any graph until we get all the way up to fucking 68. You got a lot of empty white space on the graph and it looks shitty. There are ways of dealing with that and you can graphically alter it so that there's like a lightning bolt on this. Something that catches the eye to make you come look at the numbers on the left. Because looking at this by yourself, if you're not paying attention to the numbers, is very misleading. Try to be on the lookout for that and try to avoid doing that yourself. Another way of misrepresenting data is 3D graphs. 3D graphs, okay, like if you're older, like me and maybe a couple of the students in this room. When 3D pie charts came out or 3D graphs came out, they were the fucking shit. We're like, this is fucking awesome. They have 3D, this looks super neat. Nowadays, most of you grew up with 3D graphs and don't give a fuck, you're like, eh. But like, let's take a look at it. This number, this color right here is matching up with 6 to 10. Purple over here is matching up with 11 to 15. It looks like this color right here has a lot bigger piece of the pie than the purple, based on color on my screen. If I come look at the numbers, 6 to 10 is 25%, 11 to 15 is 22%. They are really close in value. If the pie chart was a regular, like, not 3D, but like 2D, the wedges would look about the same. Here they don't. 3D graphs make whatever's closest to you look bigger than it should appear. Kind of like the whole side view mirror, the things in mirror are closer than they appear. It's kind of like that shit, like the T-Rex coming, it's that shit. So, like, avoid 3D graphs if you can, and when you're looking at them, try to keep that in mind. Sometimes they'll put other information, like another table to look at over here, so you get the values. That's it, that's all I got for you today. GTFO, have a good night. If you need have any questions, I will stick around at 7:30. Everyone leaves, I'm leaving. But if you have questions, I will stay till 7:30.